Okay, let's get started. We're going to do the Solinteg MHT 25 to 50 kilowatt hybrid inverter on and off grid paralleling solution, also with DC generator solution introduction. And we will talk about this solution from 6 aspects. The first one will be the solution introduction, and the second one will be the strategies, and also next is solution wiring, configuration, case study, and Q&A. Let's get started from the first part, introduction. So what is on and off grid paralleling solution? I think you may heard about this before because in Africa countries, some of your countries may encounter some, power grid unstable problem or power outage problem. So in that case, you may need the inverter to have the backup output to enable the inverter to output power to support some critical loads. And also, if you connect some big loads with the system, like a CNC machine, you may need a big power output of the inverter. So in that case, we needed to parallel the system to output a bigger power, to support some CNC machine, some big loads. So Solinteg, we have the off-grid parallel solution support up to 4 units, which can extend our inverter's capacity up to 200 kilowatts. And we support our inverter, as we mentioned before, we support actually 7 work modes, not 6. This very small update for the work modes. Now we have a new mode called TOU, and the previous presentation was made 2 years ago, so not mention this one. You just need to know we support 7 work modes, and this 7 work mode not only support in single unit, also for the parallel system. And for the diesel solution, some countries they not only facing the power grid unstable, they also have the big issues like they facing a very long time power outage in a day. For example, maybe 20 hours power outage in a day. So in that case, the power stored in the battery cannot meet your daily load consumption demands. So the customer may need to add a DC generator in their system to ensure stable power supply. I have been to South Africa 2 years ago, and there every day they have power outages. Almost. So a lot of hotel or restaurants, they prepared a DC generator for emergency power supply. So with this kind of demand, the customer if they have the Solinteg energy storage system, they can connect their DC generator with our energy storage system to have the uninterrupted power supply. And one more important thing you have to know is if the DC generator is connected in the system, the inverter and DC generator cannot support the loads together. Only one of them can be used to supply the loads. So you have always to make sure the loads connected in the system always smaller than the DC generator's power class or the inverter's output power. Okay, on this slide, we will show you the solutions we have for the parallel, and you can see we support a single unit work independently, and we also support parallel solutions like on and off grid parallel, or just off grid parallel, or just on-grid parallel. And for the on and off grid parallel, this solution suitable for the scenarios there with power grid, but usually they have some power outage problems. And the second off-grid parallel solution suitable for the scenario that for the place that don't have the power grid. For example, in the mountain or some islands, there are no power supply, so customers they can use off-grid parallel to supply some big loads. And an on-grid parallel solution is usually suitable for the places they have a relatively stable power grid, but they want to use our inverter or system to do some tradings, grid dispatching. Yeah, and this is usually used in Europe countries. Okay, this is solution list. It also can be understood as a content to help you quickly find the solution that you are looking for. The first one is a single solution with one inverter in the system, and a single inverter and DC generator solution. For this solution, the generator must be connected in the gen port of the inverter, and then we can click this button to see the detail of the solution. And here is the wiring diagram of the solution. In this solution, you can see we have the inverter from 25 to 50 kilowatts. It can connect with solar panels to get a DC power from the PV. And we can use the DC power to charge the battery. And also we can use the inverter to convert the DC power to the AC power to supply the loads, like some critical loads or some normal loads. And every load must be connected to the inverter with a breaker for the protection. And the DC generator here is connected to the gen port, the diesel port of the inverter. And the DC generator is controlled by the inverter through the DO signal. It's a digital output signal. And this is a wiring of this how to wire the inverter with the DC generator. And one thing we have to know is that the DC generator's power must be equal or bigger than 150% of the inverter rated power. For example, if you have the inverter power 50 kilowatts, the DC generator is better to be 75 or bigger. And this is the load you can connect with the system. And this smart meter we called RMM. From our package delivery package. And the smart meter must be connected between the load and the grid. And the phases of the smart meter must be aligned with the phases of the grid. L1 to L1, L2 to L2, L3 to L3. And the CT, which connected with the smart meter, must be connected correctly. Each phase also should be aligned with the phase numbers here. And the direction of the CT also should be correct. There is arrow. The arrow need always towards to the grid when you during connected the CT. So in this solution, you have to your customer have to prepare this generator by themselves, and their this generator must have the must support the DO control. Yeah. If this generator the customer using is not support DJ control, they can buy a DJ controller from the market, like from the eBay or some other place. Yeah. And for this solution, our inverter produced after November last year, we can support the DJ solution. For the earlier version, may not support this solution, so you have to check with your company if the inverter you used isn't behind before this time. Or you can ask our service team for support if the inverter you are using is earlier than this date. This is the first solution, single inverter with DJ. And the second one is we will talk about the parallel solution. And the first one is on and off grid parallel. Okay, the first one is off grid parallel solutions with power grid exist. So we can have a look. This is a parallel solution, and you can see the difference between this one and the previous one is we have 2 or more inverters in the system. And if we have more inverters in the system, we must define one inverter as a master and the others as slaves. So normally the inverters that connect with the smart meter or that close to the EDA box can be set as the master inverter. And you can see for this solution, every inverter on-grid output connected together to the EDA's inverter on-grid port. One thing I have to mention, for the off-grid parallel solution, we need additional accessory, which we call EDA box. Also, you can call this backup box. This box must be installed here for the protection purpose, because sometimes when the when the system switch back from the off-grid to on-grid, there will have the very big rush current to the system. And if you have a big load connected in the system, and so at that time, all the power from the grid will be fed into the master inverter, and the components inside the master inverter sometimes is not big enough to bear this kind of big current. So we need additional device, which we call backup box, to bear this big current to protect the inverter not to be damaged. So this is very important to know. For the off-grid parallel solutions, EDA box it must be connected. So we can see on-grid port of the inverter, of all the inverters connected to the back box on-grid port, and the backup port of all the inverters connected to the back port of this EDA box. And your backup load also can be understand as the critical load connected to this port, and the normal loads and the grid connected to this port. So this EDA box also have the PCB board inside to get the signal from the inverter when it should be started to work. So we have the communication cable here with the EDA to the inverter, to the master inverter. And also smart meter is required in this system. One more important thing we have to know for using this application, all the inverters power class must be same when you connect them in a parallel system, and the battery's capacity also should be same. Otherwise, the system will have some kind of bucket effect problems. For example, if you use a small inverter like a 25 here and another one is 50, so the inverter's output will be limited to 25. This is bucket effect. And they also have requirements for the firmware version. It must be meet this kind of version. Yeah. Sorry. And then next one is the totally off-grid parallel solution. For this solution, the DJ is can be connected to the grid port to pretend as the grid. We can have a detailed look of the diagram. Here you can see this one, as I mentioned before, this solution is suitable for the scenarios there is no power grid exist, like in the mountain or island, some remote areas. So in this situation, the DC generator will act as a grid to give the voltage frequency signal to the inverter to ensure the inverter can output the power normally. And the connection between the master slave inverter to the EDA box is same as the previous slide. On-grid side connect together to the backup box on-grid ports, and the back side connect together to the backup box back port. And the only difference is here the DC generator not connect to the jam port, but directly connected to the grid port of the inverter. Yeah, the grid port. This one, the on-grid port. And the requirement for the solution is same as the previous one. All the inverters must be the same power, and the battery capacity also should be same. And we also need the firmware to meet the demands. And the rated power of the DJ must be 100% 50 higher, yeah, equal higher compared with the inverted power. And the next solution is the off-grid parallel solution scenario 3 with DJ and the grid. And this is suitable, sorry. Okay. This scenario, this solution actually suitable for the places they have power grid, but they usually have the power outage problems. So we can use this solution. This is the most complete solution. As we can see, this system not only require inverters, batteries, PV panels, EDA box, and the smart meter. We also and the DC generator. We also require a new device which we call ATS, automatic switching device. This ATS is installed between the DC generator and the grid, and if there is power grid, the ATS switch will be towards to the grid side, so the power supply of the system will be will from the grid. But if the grid is shut down or grid lost, so the ATS will switch to another side. At that time, the DC generator will be automatically turned on to supply the power to the loads and also charge the battery. But this depends on the settings you set for the DC generator. Normally, our DC generator not only can supply the loads, it also can be configured to charge the battery. We will introduce this part later on the application settings. And the other part is similar as we showed you in the previous slides. And the requirement for this solution is also same. We need to confirm all the inverters capacity and the power class, the battery capacity should be same, and the firmware version meet the demand, and the DC generator's power should be 1.5 times of the total power of the system. And next solution is the purely off-grid parallel solution without DJ and grid. This is suitable for the scenarios that there's no power grid in the place, and the customer also don't have the DJ in their home or in their company. Yeah, we can have a look the wiring diagram. So this wiring diagram for this kind of solution, this is very simple. No power grid, no DC generator, just inverters and some loads and the PV panels, battery. So it's the PV panels provide DC power to the inverter. Inverter convert DC power to the AC power to supply the loads first. If there supplies power, it will be used directly to charge the battery. And if in the night or in the cloudy days, the power from the PV is not enough, so the battery will discharge power to supply the loads. Yeah. So this one is very easy to understand. The requirement for this solution is same. All the inverter must be same power, and the battery will be same capacity. And also the firmware version requirement also same as the previous solution. And the last one is the on-grid power line. As I mentioned before, this solution is normally used in some countries. They have steady power grid, like in some European countries or in China. Yeah, we can have a look. So this on-grid paralleling solutions, we parallel the system on the on-grid port, this one, and for the backup port, the load just connect independently to every inverter, not as we show you before, connect in parallel. So every inverter have their own backup load. And for this case, the customer also can connect this diesel generator and through the ATS. So even though I have mentioned before, this solution suitable for the countries that they usually don't have the power outage problems, but for some special cases, like in the winter, if there is a heavy snow and they break down the power supply, so in that case, we can still use the solution to make the ATS switch to the diesel generator side, use the diesel generator to supply power for this kind of emergency scenarios. Yeah, the requirements for this one, yeah, is same. And this is an introduction for the ADA and the ATS. This is the circuit design of the ADA, and yeah, this is also the inside part of the ADA, and you can see this part is a contactor with which can bear the current up to 400 amperes. So that's why at the beginning I mentioned for some parallel system we need a EDA box to bear the rush current from the grid when the system switch from the off-grid to on-grid. Yeah. And normally for the inverter, the maximum current it can bear is like 100 amperes around. But for this device, this can bear the current up to 400, depends on your choice. We have different versions like 150 or 300 and 400, yeah. And yeah, this device can help the system to facilitate the seamless switch over between on-grid and off-grid applications. Also can ensure steady operation. And this is the ATS. This device actually is not provided by Solinteg. The customer have to buy the ATS from the market, but normally all the ATS from the market can be used in this solution. Yeah, if it and normally for the ATS, they have two different power source. One we call the main power source. This usually used to connect to the current, and another one is the auxiliary power source. Yeah, this is used to connect to the second power source, like the generator. And the ATS also have some control method like NO or NC control. NO means normally open and NC means normally close. So this is too technical. You just have to know. We need the ATS to be installed in system for some special scenarios. And this part is the wiring between the EDA box and the ATS. So we can have a look. This COM2 is a connector from our inverter. This one refers to this one, yeah, COM2. So there are 20 pin connectors in this connector, and the pin 15 and the pin 16 is used to connect to the ATS. Yeah, you connect to the NO or NC depends on the ATS you choose. Normally, the electrician or installer, they know this part, yeah. And this main power source is connected to the green port of the inverter, like this one. and this one auxiliary power source to connect to the generator port of the inverter, like this one. And the additional backup box will also connect to the grid port, or the back port depends on the definitions of this back box, as we show you before. This port is to connect to the this port is to connect to the backup port of the inverter, and this one to connect to the on-grid port of the inverter. Yeah. And this one connect to your critical loads such as refrigerator or routers. Yeah, some devices you think is very important. You want to use it even the power grid is lost. And this slide talking about some notice we're using this solution, including the notice from the inverter part, from the PV and the battery part, from the other devices. And we can have a quick look. And the first one is the quantity. As we mentioned before, our off-grid paralleling solution now is supported up to four units. And in the future, we will extend this to 6, but currently it's 4 at the maximum. And all the inverters model power class must be same. For example, the 25 kilowatt inverter must be parallel with another 25, and the generation. I'm not sure if you know that Solinteg will offer 2 generations inverter for the 25 to 50. So the generation also cannot be mixed. Generation 1 inverter connects to generation 1, and generation 2 connects to generation 2. And for the PV and the battery, the PV strings and the battery capacity to connect to each inverter needs to be equal or basically equal. Not have a big difference. And some other device like a dongle, the Wi-Fi dongle used to transfer the data from the inverter to the server. So every inverter have to connect independent dongle for the communication. And a smart meter, only the master inverter needed to connect the smart meter. Not all the inverter need this one. Yeah. And for the EDA box, one system connect to one EDA box. And for the DC generator, the DC generator must be equipped with the DJ controller or DO signal. And for the ATS, it usually have normally open output signal. And the breaker, as we show you on the diagram, every inverter needed to connect about 5 breakers, like the on-grid output part, the backup output part, the inverter the load part. We need about 5 breakers. It maybe vary a little bit, depends on the solutions. You can see here. Yeah, this is the breakers we mentioned. For this case, we need more breakers. Yeah. And another notice is the phase sequence of the decelerator connected to the inverter. For the 3-phase system, they usually have 3 fire wires and 1 neutral wire and 1 P wire. So we have to make sure the decelerator's fire wires must be face of the fire wires must be aligned with the inverters, like L2 to L2, L1 to L1. And this communication part notice, the first one is cables between the inverters. We require you to use the shield twisted pairs for the CAN communication. That means this cable. We need to use shield twisted pairs. And the resistors, and every inverter actually they have the resistors inside, as we can see this one, the resistors. In the parallel system, we have to make sure the first inverter, the master inverter, usually we define the master inverter. We usually use the first or the last inverter as a master. So that's why here we mention the master inverter needed to turn on the resistor, and the last inverter also need to turn on the resistor. If you don't do this, there will have some communication problems during the operation. And the next part is the configuration of the parallel system. So before we do the configuration, we must to ensure that we have finished the installation of the wirings, and we also have created a power plant on the mount platform in Integ Hub. This is the Solinteg mount platform. From your company, maybe you have your own application, but anyway, the customer must have the power plant in the monitor platform. And they have added this inverter to their power plant. And also the firmware version of the inverter must meet the requirement. And we have to set the role of every inverter. Yeah, the inverter in the first or in the last must can be set as the master, and the others can be set as the slave inverters. And we have to configure the work mode. For the work mode configuration, you just need to configure the master inverter's work mode, and the other slave inverter will automatically sync to the masters. Yeah. And the next step is we have to set the phase sequence of the inverter. Even though we support the auto adaptation of the phase sequence, for example, if the installer they make the phase not aligned during the installation, we can support the auto adaptation of the phases, but we still suggest the customer to check the phase sequence when they install the inverter with to the grid or to the generator. And the last part is custom switches. This switch is just for some professional installers to operate for some other purpose. So we usually don't suggest a customer to operate these switches by themselves. And this is some configuration introductions. You can see the first. This is the off-grid paralleling configuration on our application. So the first one is if you have the power plant, so you can log in your account and to go inside the power plant, and you can click this device button to find all the devices that are connected in your system. And you can select the master inverter to set to check if the firmware version of the master inverter meet the requirement, and also check the slave inverter firmware version meet the requirement or not. If the firmware version is too low or not meet the demand, you can contact our service team to upgrade the firmware remotely for you. And after you have upgraded firmware or you check the firmware meet the demand, we can set the inverters that connect in the system. As you can see here, if you have the two inverter parallel in the system, so you can set the inverter parallel units to two, and if you have more inverter connected, like 4, so you can set this number to 4. And after setting the total units connected in the system, you have to set the sequence for every slave inverter. So the first is slave inverter next to the master, usually is set to it will be set as the first one, like yeah, and another one next to the first slave will be set as the second one. Yeah. And after you send the units that are in the system and the sequence of the slave inverters, you have to configure the work mode. As we mentioned before, we support 7 work mode for this first generation of the inverter. And each mode, how each mode works, I think Valeria already gave you the introduction. So you can select the work mode according to your preference. For example, here we select economic mode, and after select the mode, we just click a confirm button. And you just need to set the work mode on the master inverter. And after the mode is selected, all the slave inverter will auto sync with the on-grid inverter, sorry, the master inverter. And this slide shows you how to set the phase sequence. As you can see, we just click this configuration button and go to the feature parameters and click this grid phase sequence settings, and you can select the one from the list. Like here, we select auto adaptation, but for some special cases, especially customers use very old disk generator, they may have to select another choice, but this usually needed to be operated with the guidance from our subsystem. Yeah, here you can see for the African region, it's recommended to select a positive sequence. This because sometimes the disk generator or power grid used in your country may have some unstable problem. So you'd better select this one. And the next slide is a custom switches. Yeah, this switches, we have a default settings for these switches, and we do not suggest you to change the status of these switches without a guidance from the Solinteg support team. Yeah. And the next part, we will show you how to connect this generator to the system. The first one is, after you have a plant created in the system or the application, you can click the devices to find your power plant, and you can click the plus button to this page, and we can connect the third-party devices to select the third-party device that you are going to connect. For example, here we select this generator, and we can give the name of this generator, and we can also select the superior device that we are going to tie or to bind with this generator. And after that, we can click the red arrow to select the select the generator connector place. As we mentioned before, we introduced before for the solutions, the generator actually can be connected to different places in the system. For example, we can connect to the gen port of the inverter. We can also connect to the grid port of the inverter to pretend as the grid in the some island or mountains without power grid. We can also connect this generator through the ATS device. So you have to define or to select which port you have connected your this generator. This must be selected correctly. Yeah. And after select the access method of the generator, you have to set the control mode of the generator. We support 3 different control for the gen port and ATS port. They are manual control. That means you can manually start or stop the this generator. And also we support automatic control. This means If you select this one, this means when the power grid out breakdown or just fails, the this generator will automatically switch on to supply the loads or even charge the battery. And SOC control is it's another way to activate your generator. For example, if the power grid is falls down, and the generator will not start immediately. It will wait the SOC level reach the limitation you have set here. For example, when the power grid falls down, the SOC of the system is at 80%, but the SOC value you set for activate the generator is at 50%. So the system will first use the battery power and the PV power to supply the loads. Only when the SOC of the battery reaches 50%, the DC generator will be activated to supply the loads. Okay, and for the if the DC generator is connected to the grid port of the system, we only support two control methods, which are manual control and SOC control. And this slide shows you how do you want to use your generator? Do you want the generator only to supply the loads or supply the loads and charge the battery? So you can select this. You can configure this in the output mode. Yeah. And after that, there still have some parameters you need to configure, like the nameplate power rating of the generator, the maximum power limit of the generator. This kind of information you can configure according to the nameplate of the generator. Yeah. So let's go to the second part, the case study. This actually is the case we have installed in Myanmar. And this is a parallel system with 250 kilowatt inverter and a battery with 140 kilowatt hours. Sorry, two battery. And this generator power is 200. Yeah, this is the situations, the problems that the customer encountered before installation. This system, like they have to pay a lot of oil for using for the generator, and also they have the big noise problem in the night. And yeah, sometimes they have some difficulty to get the diesel the diesel fuel. So after the installation, the customer, this is what they can get, or they can benefit it from the installation. And the next part is some frequently asked questions. So, what is the requirement for the CAN cables between the parallel system? Yeah, this must be the shared twisted pairs. And the rated capacity of this generator connector system, it must be 1.5 times higher than the rated power of the inverter. And yeah, can we realize the zero export limit to the generator? Yes, we can do that. If we cannot do that, this behavior will damage the generator. Yeah, so we can do that. And if there is an inverter field in the parallel system, how will the system operate? It depends on the inverter is the master or slave. If the inverter is master, the system will not work properly. But if the inverter is slave inverter, the system will isolate these broken inverters and the other inverters still working properly. There are some other questions from the customer, like how to keep the system running if the master inverter fails and the replacement inverter hasn't arrived. So for this case, the customer can define another inverter as a master, and they can change the smart meter connection to the new master inverter and follow the instructions we introduced before to configure the parameters, the masters, the units of the system, the slave sequence, yeah, as we introduced before, one by one. And how to choose the ATS. Here is the some important information you have to be aware when choose the ATS. Yeah, usually just ensure the current of the ATS is 1.25 times bigger than the total power of the loaded battery. Yeah, like this. Yeah, you can calculate according to the formula here. And because we have published a V1.0 version parallel system, and then this one is a version 2.0. So there are some more features in this new version solution. So if the customer want to realize all the features we have introduced in this slide, they have to make sure their firmware update to this version or a newer. And they have to follow the application configuration step by step, as we show you from slides P22 to P27. Yeah. So that's all the introduction for the parallel solution and the diesel generator solution. So thank you.